modeling question, and it's based on a quadratic function. We can see that it's quadratic based on the quadratic part of the equation there. The first part is to sketch the curve, so we need to go to our calculator, y equals, and you can see I've typed in the equation of the curve, and we can now graph it. Now looking at my graph, we can see that it's not quite long enough because I can't see this x-intercept. So I'm just going to go to the window and I'm going to make the x-axis slightly longer. And we can see that we can start to see it, but maybe a little bit longer would make it clearer. Okay, now we can start to see. Now, given that the axis has been drawn for us in the question, it doesn't really have this negative side, and we're told that h is the height of the ball and x is the distance that it's travelled, it seems like the ball is being thrown and travelling in this direction, in which case we don't really need this negative part of the graph anyway. So we need to find the key points of this curve before we can graph it. So I'm going to find the zeros first of all. So I'm selecting to the left, selecting to the right, and then pressing enter a third time. And we can see that that's going to be 14.9 to 3 significant figures. So it crosses the x-axis at 14.9. We also need to find where it crosses the y-axis. So that's a 0, that is a value when x is 0. And we can see that when x is 0, y is 2.103, or to 3 significant figures, that would be 2.10. And we need the 0 there to show that there isn't another number there instead, or to show that we've rounded it to 3 significant figures rather than 2. The other thing we could do while we're looking is to find the maximum point of my curve. So there's a maximum point somewhere here. There we go, and it's at 3.7655, 2.3769, and so on. So we can draw this curve, so we can see it actually goes up before it goes down. That's not a very smooth curve, so it goes up before it goes down. And we have this maximum point here, which I'm going to label to 3 significant figures as 3.77, comma, and then it's 2.38 as my maximum point. So that's my sketch done. I should label my axis. So this is x, which is the distance, and then this is the height of the ball here, or h of x. So we then need to find the maximum height of the ball during the motion. Now I've actually already found that information. You cannot leave your answer as simply a coordinate point. It's asking what is the height, and the height is the y-axis, so it's 2.38 meters high. So you need to write down the specific value rather than just the coordinate point. And then for part C, the height of the net is 107, and they serve from a distance of 11.98. So that means that somewhere here at 11.98, there is a net, this is my net, which is a height of, and I think you actually had here 1.05. So this is a net which is a height of 1.05. So once we have that, we can go to our graphic calculator to work out whether it crosses over it. So there's 2 ways of doing it. I would say the easiest way is let's find the value at 11.98. So let's find what is the value of the curve at 11.98. So the curve at 11.98 here is at a height of 1.73, so 1.07 to 3 significant figures. So that's the height at 11.98. Now the net is only 1.05, so that means that the ball went 2 centimeters above the net. So yes, it did cross the net. Now to get both the marks there, you need a method but also a reasoning mark or an answer mark. So yes, it does go over the net, but I need a method shown. That method could literally be what I've drawn here, showing that I've looked for the net and that I've found the value of the net at that point. An even nicer way would be to show that for the function that I have, which is h of x, so when h of 11.98 equals 1.07, or to simply show that this is a coordinate point 11.98, comma 1.07. So by showing that I found the height of the ball, the line, the graph at that point, and to show that it's higher than the net, that would be enough working that I then need. So for this question, in terms of the graph, there was 1 mark for the shape of the curve, so having that negative quadratic. There was 1 mark for having the axis intercepts, so for these 2 points here, and then there's 1 mark for having the maximum written on as well. For the second one, there is 2 marks, 1 for the height and 1 for the units, and then we've already talked about the marks for C.